Hello, everyone. Um, my name's Steven, and I'm joined here with Caroline. If you want to say hello real quick.
Hi guys.
All right, so for our lab, we're going to be doing this lab number 16, electrical energy and light bulbs. How does the arrangement of light bulbs that are connected to a battery affect the brightness of a single bulb in that circuit? So I'm just going to read to you guys a little bit of the background and history of this, just kind of paraphrase it so you have an idea of what we're doing. So the purpose of this lab is to introduce students to electrical circuits arranged in series and in parallel. So if you didn't know, there's kind of two ways that you can wire anything electrically. Series means that you have a direct connection to the battery, and any components that you have in the circuit, the current has to run through everything in a series. And then in parallel, everything is connected directly to the battery itself. So it's like you have the battery wired to this and the battery wired to that. And so the current has multiple different paths that it can flow through, or it can flow parallel to each other. So this lab will give students an opportunity to track how energy and matter move through an electrical system and examine the relationship between the structure and function of electrical circuits. Students will also learn the difference between data and evidence and the nature and role of experiments. A basic circuit has three components: a voltage source, a resistor, and wires connecting the resistor to the voltage source. So in your bag, you will notice that we have these D batteries as well as these little blue plastic battery holders. We've got bags full of alligator clip wires that we can use. And then we've also got these little light bulb holder blue plastic things with um, tiny little light bulbs. And so we can use these things to create different types of circuits. Um, In the case of the light bulb, the voltage or electrical energy provided by the battery can be used to produce light. The mathematical relationship between these three components of the circuit is Ohm's law: V equals IR, where V is voltage, I is current, and R is resistance. The guiding question asks about the brightness of a bulb. The term brightness is often ambiguous because it can refer to the amount of light given off by a source, but it can also be used colloquially to mean a different shade of color. In this lab, brightness refers to the total amount of energy given off by a light bulb. So there's another material that we want you to get. So if you go to the App Store, you should be able to find this Lux Light Meter Pro app. And so you can use this. So this is what the app interface looks like to kind of figure out how bright your light bulb happens to be at a moment. And so I've found that if you take your camera and you put it directly on the bulb while it's lit, you should be able to get somewhat of a decent reading there. And I think it would help to probably make things more dark, so it can see that more easily. Um, Finishing up here, for circuits that contain two or more bulbs, the situation can get a bit more complex. When the number of light bulbs are connected in series, the total voltage used by the circuit is still equal to the voltage supplied by the battery. However, the total resistance of the circuit increases and the current flowing through the circuit decreases. If all the this is kind of some background that about series and parallel. So in series, the voltage drop across each bulb is equal, since they all have equal resistances. Um, and then where is it? Here it is. When light bulbs are arranged in parallel, the total resistance of the circuit is found by the following formula: 1 over R total equals the sum of the inverse of the resistances, which is kind of confusing, but here's your formula for that. Um, So yeah, you can go back and find this section here at the beginning, and it'll give you a little bit of that information that you need for series and parallel. And now Caroline is going to explain a little bit more about your process here.
Hey. So basically what you're going to do is use what you know about circuits and the relationship between structure and function, and you're going to design an experiment to develop a rule that will allow you to predict the brightness of a bulb based on how it is arranged in electric circuits. So again, that is our guiding question. How does the arrangement of light bulbs that are connected to a battery affect the brightness of a single bulb in that circuit. You'll want to keep in mind the ideas of Robert Boyle that scientific rules need empirical support, and it is important to control for all factors that might influence your results during the investigation. Once you develop the rule, you'll need to test it to determine if it allows you to predict the brightness of a bulb in a wide range of different circuits. So Stephen went over the materials. You should have size D batteries, battery holders, small light bulb holders, electrical wire, um, safety glasses. Use your own discretion with that. Obviously, don't hold the light bulb up to your eye with the wires and do something silly. And then also that app, it should be free on iPhones. Um, again, take proper safety precautions. And so the first step with getting started is to learn about how the number and arrangement of bulbs in a circuit affect the brightness of a specific bulb in that circuit. So you need to determine what kind of data you need to collect and how you'll collect it, and then how you will analyze it before you begin. If you look at page 291 in our lab handouts, it kind of breaks it down to you with a few bullet points on how to determine what type of data you'll need to collect, and it gives you some questions that will kind of get you on the right track, as well as how you will collect your data and then how you're going to analyze your data. The second step of this experiment is to develop the rule that you can use to predict the brightness of a bulb in a circuit. Once you have the rule, you need to test it over and over, um, see if it allows you to accurately predict the brightness in several new circuits. What that means, one that you did not use to develop your rule. The results of this will allow you to demonstrate that your rule is valid, but it will also show you that it's a useful way to predict the behavior of a light bulb when it's connected to a battery and one or more other bulbs. So modify your rule as needed. Um, and yeah, have fun. All right, guys, one more thing. The connections with the cross-cutting concepts. While you're working through this investigation, you need to think about the following things. The importance of tracking how energy and matter move within the electrical systems, the relationship between structure and function in nature, the difference between data and evidence in science, and the nature and role of experiments in science. That will help keep you on the right track and keeping your experimental design organized.
We'll see you guys arguments boards in a couple of days. So see you then.
Bye.